I did print, as you guys can see, or have them copy for us all of your new packet for the rest of Unit 2. But in typical me fashion, I didn't like 2.8, so I scrambled to get some other notes put together, which is what I handed you. So today and tomorrow we'll do 2.8 notes and homework on those green pieces of paper. And then when we come back, we'll start 2.9 that week, and that's when I'll give you the actual normal packet that you're used to seeing, okay? The other thing is, so we're working today and tomorrow. In class, you'll get it done. You won't have homework. When we come back, that will be Monday, December 2nd. That's when we'll do the Unit 2 progress check. That's the College Board thing, 10 homework points. I'm going to give you that Monday to work on it in class. It won't be due until like later in the week. But I opened it now just in case you know you're not going to be here the week we come back, or you are bored over break, or tonight you want to start working on it. Totally fine. I just figured why not open it, so I did. But it's still not due till December 6th, okay? So that's coming up, and that Monday we come back, bring your laptops. We won't be learning. We'll just be working on this, and I'll have a homework check that Monday. Okay, so homework check and Unit 2 progress check when we come back. Also that week will be your next quiz. Don't worry about it now. I'm just giving you a heads up. It'll be our second quiz, so finally some of you can get that first one dropped if you didn't do so great. Both will be in AP Classroom, that whole thing. Okay. Also, tomorrow, extra credit opportunity, pink sheets. So bring your pink sheets. I'm going to put it in the quiz category, which is where we are falling the shortest. The most short? Whatever. But that's where it's going to go. All right? I want to talk about one thing from the test. And on your test, the first day's FRQ, okay, there was a question where you had an exponential function written in table form, and the last step was to sketch the graph. And most of you sketched it perfectly fine. Where we went wrong was the range. So I want to talk about this because this is the second test now where the number one glaring mistake that people made was on the range. Okay, so we're missing something with that. So I want to talk about it really quick because what would happen with these people at the highest scores is probably this. For most people, it was this and maybe one other thing. It could be a 97. It had to be more than just this. But anyway, let me show you. So we had to sketch the graph, again, which most of you did fine. Here's your asymptote. You had to label your x-intercept and sketch a graph. So most of you got all 4 points for this. Where we lost points was further up on the FRQ where we had to do range. So let's talk about the range. The range, domain and range have to be least to greatest, first of all. Always. It's wrong. Even if it's the right numbers, if you put them in reverse order, it's wrong. No points, okay? Has to be least to greatest. So domain, we always say negative infinity to infinity. Is that just the way we do it? No, that's the way it's supposed to be done. Least to greatest, right? Same with range. It has to be least to greatest. So as I travel up the y-axis, I get to where the action is, and that's right above the -3. So -3, but not including it, right? Because you can't have a point on the asymptote, but it's all the numbers right above -3 to infinity. So a lot of you had just lots of variations on this, a lot of towards negative infinity. Even though your picture looked like this, your range would be wrong. So just be aware of that because that seems to be a consistent mistake we're making overall. Okay, good? Yes? Yeah. Okay. All right. So, inverses. The beginning of this is going to seem a little muddled. We're going to write some definitions down. Then when we get to the actual math of it, you guys are going to be like, this is really easy, okay? Because it is. Nothing about this is hard. But I will tell you, I spent more time planning this section than any section so far this year because this is what made me cry last summer. I literally was sitting at a table with a group of teachers in a room, huge convention center of 385 teachers, crying over inverse functions because I was so frustrated. There is nothing that we disagreed, argued, discussed more than this topic last summer. And so my goal this year is that not one of my students is going to lose a point on this question on the FRQ. I already know your FRQs. your FRQs on the exam, we're going to study, memorize what the words are, like exact words that we have to say, and it starts today. So I'm going to be having you write some definitions to teach to you, but understand we don't really have to have them memorized until we get to the exam. So I will really cover 2.8 again when we're reviewing for the exam, and I'll remind you of this moment where I'm like, remember when I said I cried over the summer? This is the definition. First thing is this, okay? The definition for the word function, okay? We in this class throw that word around all the time. We talk about function this, function that, there's the function, here's a function, everybody's got a function. What is a function? And it has a very specific, definitive definition that we have to know, and that's this. Each input has exactly one output. What's another word for input? X, okay? So you could say each X value has exactly one Y value. This is something verbatim we're going to write on a note card in quarter 4 and study it. We're going to know that definition, okay? Now, what does that mean? A function, that definition, means it passes a vertical line test. Remember vertical line test? A function, it has to have no repeat X values, that kind of thing, okay? What we're talking about is the inverse of a function. And you might remember this. Inverse functions undo. Well, let me talk about the word relation again real quick. A relation is just a set of ordered pairs, okay? A relation could be a function or not, all right? So let me show you some examples of relations. This is a relation, just a bunch of ordered pairs. This is a relation. It's a bunch of ordered pairs just in graph form. This is a relation. It's a bunch of ordered pairs in an equation, right? If we graph that, it would be a whole bunch of ordered pairs, points on that line. So a relation is just like a generic term, okay? If it's a function, then it meets this criteria, okay? So an inverse relation will undo a given relation. So given some points, we flip or switch each X and Y to get the inverse, okay? Now, just because we flip it doesn't mean it's a function, okay? And I'm going to show you exactly what I mean by that. But let's write one other, well, second of 3 definitions right here. If the inverse, so if we flip the X's and Y's, okay, so now we have a new function, and I promise I'm going to do some of those in a second, is a function, it's known to be this word. This is a really important word. Invertible. Invertible. That is the word on your AP exam that says, is the function invertible? Well, guess what? Nowhere in any of the notes that I taught with last year used that word. I didn't teach that word, okay? I failed my students by not teaching them that that word is important and this is what it means. Not making that mistake this year, okay? So if the inverse is a function, it's known to be invertible. Which is each input, it's looking kind of familiar up here, each input has exactly one, but there's one word difference here, unique output. Okay? So let me say this again. We know what a function is. Each input has exactly one output. If the inverse is also a function, so if we flip the X and Y values, if that's a function, we call it its invertible, okay? And what that means is each input has exactly one unique output. This wording makes my brain hurt, okay? I'm going to try and explain it to you with a picture. My students tend to understand this better than me. There's something about this that is very confusing to me. So let me show you what I mean with a picture. Here is a graph of a horizontal line, okay? This is y equals 4, let's call it, okay? It's a horizontal line, and that would be considered a function. That is a function. There's, like, it passes the vertical line test. There's no repeat X values. Each of these X values have exactly one Y value, okay? That's what that means. Now, if I find the inverse of that, I'm going to switch the X and Y, and you'll learn more about this in a second. but that would make x equals 4. Switch x and y. Is this a function? Is x equals 4 a function? No. It does not have, each input does not have exactly one unique output, okay? And so we're going to really break those two definitions down more later, but I wanted to throw that out to you right away, okay? And I'm going to come back to this idea as we go through some examples. So stay with me for a second. What we're going to do is talk about inverses as it relates numerically, graphically, and analytically. We do this all the time in this class. We talk about stuff with tables, then we look at it in a graph, then we look at it in an equation on the next page, okay? So very first question is find the inverse relation. Here's a relation, set of ordered pairs. All we have to do to find the inverse relation is flip them. So my y's become x's, my x's become y's. That's it. Okay? Now, the original table, this table that they gave us, is a function, right? Each input has exactly one output. Look at it. Each input has exactly one output. However, the inverse is not a function because there are output values that do not have unique inputs. An example of that would be x equals 2 for y equals 3 and 6. Look, we have repeat x values, right? So 2 is used twice in our flipped relation. So let me ask you this. Was our original table, is this invertible? Is this invertible? No, because the inverse is not a function. This is not invertible. And again, we kind of wrote 3 definitions here. We will really focus on those more later. I don't want you to stress about the wording because the actual finding of inverses is not difficult at all. And you're going to see that. We just did one, right? We just did it in the table. You have 2 homework problems where it's just flipping a table, okay? There's a question on the quiz that here's a relation, which one is its inverse? And you just have to find the one that flipped the table, okay? All right, let's look at another picture. I'm going to change the directions to this one. Just stay with me. Let's call this graph f of x. Call it whatever you want. Okay, let's just find the domain and range of f of x. What's the domain and range? Now, there's no arrows anywhere, so there's no infinity anywhere, okay? So the domain least to greatest, the smallest x value we use would be -2, and I would use a bracket because that point is part of the graph, right? It's colored in. -2 to 4, okay? That's my domain, including that endpoint. And the range would be the smallest y value to the biggest y value, right? So that'd be -1 to 3, right? Domain and range, simple concept. What we're going to do is find the domain and range of the inverse of this. Now here's a new symbol for you. The symbol for inverse is this. It's called, I never say it right. What's the wording? F inverse of x. It's the inverse, okay? So as long as you put that -1 there, it could be a g, it could be h, that -1 means inverse. And look, guys, all we have to do to find the inverse's domain and range is flip the domain and range of the function because those are x's and y's. You have to remember, inverse, flip x and y. Flip x and y. So domain is your x's, range is your y's. So if we just flip them, we now have a new domain and range, and they just flipped. We didn't have to use the graph for it. It's just knowing that fact. Flip your x's and y's. So if I took all these points off the graph, made a table of values, flipped them, graphed them, this is the domain and range we would see. But we don't have to do all that. We know it's going to just flip. Okay? Next page. So we did it with a table. We talked about it with a graph. Let's talk about it analytically, known as in an equation. okay? The steps are here, but they're really, really simple. If we are asked to find an inverse, we switch x and y, all right? So you know f of x is y, right? So switch x and y. But with an equation, there's one more thing we have to do, and that is solve for y. Switch x and y, solve for y. And you're just using your algebra skills, guys, to isolate the y. We're going to add 7, divide by 3. Show as much or as little work as you need or want to. I don't need to see it. So I have x plus 7 equals 3y. Divide everybody by 3. Again, you don't have to show these steps. And I would get y equals, and you can leave it as one big fraction like that, or you could split it up. You could write x over 3 plus 7 over 3, but that's perfectly fine. Something to note, the domain and range of this would be all real numbers because it's a line, okay? This is a line because it's linear. The inverse of a line is also a line. Look, we found the inverse. It's also a line, x the first. Domain and range would be all real numbers. It's also going to always be a function. So is this guy invertible? The answer is yes. We go from a line to another line. All lines are functions except for the one I showed you, which is a horizontal line, is a function, but it's not invertible. Because when you invert a horizontal line, you get a vertical line, and a vertical line is not a function. So we'll talk more about that as we go, okay? So given a function, find its inverse. We're going to do the same thing, for example. What? Tell me when you're done. Okay. All right. Look at all these steps, but then don't look at them again. These steps are what I'm going to show you how to do here. These steps are great. If you get stuck, I'm not available to help you, you're at home working on this, going back to these steps will help you do these problems, but I'm going to show you how to do it. These are the same steps every single time, okay? You might notice a little bit fancier of an equation, but we're just going to find the inverse. So guys, do these two with me, and then you have 2 in your homework to do. And it's just fancy algebra, okay? So again, we know f of x is y, and to find the inverse, we're going to flip the x's and y's, right? So I'm going to have x equals y minus 2 over y plus 3. Anywhere I see an x, I'm going to put a y. Anywhere I see a y, put an x. That's inverse. Switch your x and y, okay? Don't forget, though, we have to solve for y. So we have what you guys see is a fraction, right? You guys hate them. I hate dealing with fractions. I see division. This is y minus 2 divided by y plus 3. Let's get rid of the fraction by multiplying both sides by y plus 3. Because, guys, if you multiply a fraction by its denominator, let me say it again. If I multiply a fraction by its denominator, they cancel and you're just left with your numerator. So we'll be getting rid of the fraction. Just don't forget that what you do to one side, you have to do to the other. So on this side, I'll just have y minus 2 left, right? That's the y minus 2. And even though this looks funny, this is just distributive property, guys. It's just x times y plus 3. I'm just going to distribute. So x times y is xy. And x times 3 is positive 3x. Okay, so we got rid of one issue, and that was the fraction. Now, remember your goal. We want y by itself. We want to isolate the y. So what we're going to do is we're going to rearrange the equation. We're going to put anything that has a y in it on one side and anything that doesn't contain a y on the other side. In other words, look, look, look. These two guys are going to switch places. I'm going to bring this y over here and this 3x over here. Using my normal rules, for example, to move this y to the other side, I would subtract it, right? And I would be left with x, y, minus y. That's gone. What would I do to the 3x? Subtract it. And I don't need to see this step, so I won't show it on the next problem, just to show you. It's just crossing the equal sign, they change signs, right? And you could write negative 2 minus 3x or negative 3x minus 2. It doesn't matter the order. Okay, so this is the step so far today. I've gotten the most questions when I've walked around is like what to do here. Well, remember your goal. Keep your goal in mind, y by itself. So what you're going to do is take y away from those two. factor out not the GCF, just the y. And the reason I don't want to say GCF is because if they had like another something in common, let's pretend a 2, they both had a 2 or something, we wouldn't take the 2. We just want the y, okay? I'm going to factor out a y. Well, what's left in parentheses is whatever is left after I take the y away from these, right? So when I divide xy by y, I have x. And what's y divided by y going to be? Negative 1 in that case. It's just the reverse of the distributive property. Don't forget how to do simple GCF problems. So you can check this very quickly by distributing. You should get what you had up here. All right. And now we just have one step left. We're almost done. Now that we isolated the y, it's not a part of the binomial. We can just divide by x minus 1, right? This is multiplication. Opposite of multiplication is division. So let me show you the 3 different ways you could write this answer. Any of them would be okay with me. So there's my symbol for inverse. So just what you see is perfectly fine. That would be perfectly full credit, exactly like that. But remember, multiple choice, sometimes we write things a little bit different. We want to be able to recognize it if it's written differently. So I'm going to show you 2 other ways you could write it. A lot of times you'll see when both numerators have a negative, you'll see the negative factored out, which changes both of their signs to positive. Didn't touch the denominator. That's perfectly fine. You could see that on a multiple choice test. And one more way is instead of putting the negative in the numerator, it goes out in the middle, right in front of the fraction. In this last form, we know when we see a negative in the middle, it applies to the numerator. We don't ever put a negative in our denominator. So these 2, all 3, mean the same thing. Okay, so just understand you could see it any of these 3 ways. But you could write it any of those 3 ways. If it was an FRQ, you get full credit. Okay, let's do one more of those. Again, same steps. It takes a couple of them, and then it really does become easy. Switch your x's and y's. And then we have to solve for y. It's always going to be the same steps. You're always going to have a fraction that you want to get rid of. How do you get rid of the fraction? We multiply. I'm going to multiply this side by y minus 3. When you multiply a fraction by its denominator, they cancel. You're left with just the numerator. But don't forget, what you do to one side, we must do to the other. And then you would distribute. X times y is xy. X times negative 3 is negative 3x. Okay, fraction gone. Now let's put like terms together. I'm going to put my y's on one side, my other stuff on the other, right? So 2y, I'm going to subtract it. It'll come to this side, right? And the 3x, I would add it to the other side. You can show the work if that's hard for you to do in your head, but get your y's together properly. What's next? This is where everyone gets stuck. Remember, you want to get y by itself. Now is where we factor out the y. We'll be left with x minus 2. And again, you can write 1 plus 3x or 3x plus 1. It doesn't matter. Now, very last step is divide both sides by x minus 2. So, that would be our answer. And there's no other way to write that one. There's no annoying negatives going on in that numerator or anything. That's it. Okay? So there's 2 of those in your homework with all the steps shown. All right, last example. Skip to the page. Some of you still writing. Let me give you a second to finish. Yeah, I see a few of you writing, so I'm waiting. We're going to the page that says something about inverse at the top. The last page. There's page 3 you're skipping. We're not doing. This page. It's just one that's included that we're skipping. It should be just side by side on the other side of your paper. Find this. I know it's confusing. I just can't use that much more paper by giving you guys full sheet. So, last thing is just example 6. So what we just did is, here's a function, find its inverse, right? We just did that for 3 different problems. Switch the x and y, solve for y. Now, you're given 2 equations, and you're asked, are they inverses of each other? So the way to tell is to do what we've been doing, the composition of functions, f of g of x, and we'll do g of f of x. So we have to do 2 problems. What we should get both times is x. So we're going to do f of g of x, and we're going to do g of f of x. And the way we will say, yes, they are inverses of each other is if we get x. It's just x, nothing else, okay? And I'll show you exactly what I mean. So don't worry about that. Next line. So what we're given in example 6, look, we're given f of x and we're given g of x. And the question is, are they inverses of each other? So the answer to this question is going to be yes or no. How do we figure it out? Well, we'll do f of g of x and g of f of x. So let's start with what they wrote first. Remember how to do these. G of x, right to left, gets plugged into f of x. So I'm going to take all of g of x, right? And I'm going to plug it into f of x right there. Okay, we just had this on the last test. So that's 2. Open up my parentheses, put all of that in, minus 3, right? Now we have to be comfortable working with fractions. A phrase I've said 3 times, I think, today. When you multiply a fraction by its denominator, you're left with the numerator. So when I do 2 times 1/2, I'm left with 1. 1x. 1x is just x, right? It's distributing. When I multiply a fraction by its denominator, I'm left with the numerator. I don't need a calculator for that. 2 times 3/2 is 3. And then there's a minus 3. The 3's cancel. We're left with x, right? So we're halfway there. If I got something other than x right here, my darlings, I would not even bother with g of f of x because they both have to equal x to be inverses of each other. So let's see. F of x now into g of x. So I'm going to take all of f of x. Oh, I wish I could say that to someone. Like that. And he goes, I want everyone just to look at somebody they're not mad at. Oh, yeah, that happened during my 7th period. That girl went crazy. Okay. Okay, so what we did was we took f of x, right, and plugged it into g of x. So that's what I did here, all right? And let's simplify it. When I multiply 1/2 by 2, I'm just left with 1x, which is just x. 1/2 times negative 3 would just be negative 3/2 plus 3/2, blah, blah. Yes. They are inverses. Okay? Kelly? Me, no. Maybe you. Maybe. My brain wouldn't do that. Think about this. If you do find a shortcut like that on a multiple choice, fine, because if it was an FOD. Okay, that's it. That's it. That's it. Guys, write this down so I can put the key up. So I think I put 1, 2, 5, 6, 7, 8, 9. Yeah, B14. Right? Doesn't it say B14 on your paper? Yes, it does. Just find it. Flip around till you find it. It's somewhere. It should be next. It should be right after the last sheet we just wrote on. I'm sorry. Guys, 1 and 2 are just flipping, okay? You're just flipping the XY chart.